what they're calling the world's largest public machine learning cluster.
So I think this bodes well for a lot of the new players who may otherwise not be able to participate.
When you think of a cluster having hundreds to tens of thousands of chips, this is a pretty big deal for HPC buyers.
By and large, you can build a system for the largest typical app.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hi, Shaheen. Great to be with you again.
How are you?
Good. How are you?
All right. So we took a bit of time off since our last episode was a long episode and we treated it as a double edition.
That's right. And there was a lot of interest in Jack Dongara's interview, and that came out really well. Now, moving ahead, we're looking at some news that's come up over the last week, the freshest piece of which is TSMC and Samsung, which of course make chips used in HPC clusters, going to be raising their prices pretty significantly.
I'm shocked.
Or not surprising, but always a shock, I guess, when it happens. But when you think of a cluster having hundreds to tens of thousands of chips, this is a pretty big deal for HPC buyers.
Oh, definitely is. And of course, there is a chip shortage around the world. And when you have supply limitation, supply and demand, prices are going to have to go up a bit.
Exactly.
And I think this is especially the case for the latest, greatest technologies, where there is just tremendous demand and clients are crawling over each other to try to get capacity.
Samsung is talking about a price increase of up to 20% kicking in, I think, next year. And then TSMC, their price increase is more single digit, but it comes on the heels of between 15 and 20% increase last year.
Yeah, this is not the way Moore's law is supposed to work.
No. And
in fact, really, historically, the only time we've seen prices go up is if supply has somehow got compromised, whether there's a fire in a disk factory like there was some years ago or something like that. I think this kind of a systemic increase in demand is different and unique and new.
And I think it reflects all sorts of things going on in the world. There's sort of global inflation, certainly in first world countries, industrialized countries. And there's geopolitical instability and supply chain problems. So it's a whole host of factors.
All of that adds up.
Yeah.
That's right.
So we'll be watching that.
So really, one conclusion for the system buyers is that when can you ship becomes a very important question. And it will likely determine what configuration and what systems you're going to buy, because you may have to wait a long time to get what you really wanted, whereas you could have something that's pretty close and maybe a little bit different and you can get it now. So I think this bodes well for a lot of the new players who may otherwise not be able to participate.
Yeah. And for others, it's the worst of all worlds. You have a long wait and pay a lot more money. So
That's right.
Another really interesting announcement came out of Google Cloud about what they're calling the world's largest public machine learning cluster. It's powered by TPUs, Tensor Processing Units, version 4, and they're claiming an aggregate compute power of 9 exaflops.
Very nice. But those are 9 exaflops in reduced precision.
Yes. To me, this raises questions of if, let's say, Google decided to compete in the top 500 list, where would this come in? Or would it even qualify?
Yeah, they probably won't do that because the system is using their TPUs that are ASICs that are really designed for TensorFlow, their AI library, so to say. And it is especially good at that. And they haven't really optimized it for much else. And in fact, they recommend that if you have a lot of C++ code, or if you have smaller models, or if you really need 64-bit performance, that's really not for you. So I don't think it's suitable for anything like HPL. I think it might have a shot at HPL AI because that one is lower precision and makes up for it with iterative corrections at the end. So they might do that, but then that means they have to run it. What is interesting to me on these announcements is floating point precision, that the scientific world moved towards 64-bit computing, and that covered a whole lot of applications where error propagation could be contained and you would get decent accuracy. This was up from 32 bits and 36 bits in the older days before 64-bit. But then AI can do with lower precision. So they now do 32 bits and then 16 bits and 8 bits. And I'm pretty sure we will see 4 bits. I sometimes wonder why they just don't use integer coefficients and be done with it. But the thing is that as you go with lower precision, it's half the size. If you go to 32, it's half again if you go to 16. So data movement becomes easier. And if you've done your circuitry right, then you can actually perform the multiplications, the additions faster as well. And that's really why oftentimes when you go from 64 to 32 bits, you double the performance, is because the circuitry is set up to work in parallel on smaller chunks.
Well, in doing some basic research on these TPUs, it was noted several times it really can't do linear algebra or much in the way of arithmetic, even, which makes me kind of sympathize with TPUs because I was never very good at math either. So, uh,
Yeah,
in any
you
case,
do detect images way better.
yes, indeed. And so, anyway,
But what
uh,
you're saying is really another important point, is that these systems are really optimized for a particular workload.
right.
And that's why they have to qualify it as the AI supercomputer or a image recognition supercomputer. And another interesting part is that people want these bragging rights. You have the system and it's wonderful in a particular thing, and you can't really plug into top 500, but you still want to brag about it. What do you do? So you just qualify it with sufficient number of words to make it valid, and there you go.
Yeah, you go benchmark shopping, essentially.
Right, right. And in this case, of course, they're running their own code that has become a benchmark, and they can show how wonderfully they perform.
Mm,
But I don't know if we have seen benchmarks on this. I think this is more of a look what we've built rather than
yeah,
let me show you exactly how many exaflops it does, even if it is in 8 bits, right?
right, right. Now, maybe this is from out of left field, but our friend Rick Stevens has talked about AI based simulation really taking on a bigger role relative to traditional HPC simulations. And I wonder if a system like that could eventually play in that area.
I think it could be an add on, an accelerator, a coprocessor, so to say,
Mm,
for certain parts of the simulation, but
mm,
not for all of it.
yeah,
We've talked about also with Jack Dangara on the future of supercomputing and how it will be likely a combination of different kinds of architectures that cooperate towards a particular solution.
there we are.
Relevant to this also is a question of capacity versus capability.
Mm,
When you have a giant system like this, like exactly how often are you going to run a single app on all of it? It is possible if you have a mission oriented system like the DOE systems are, then you do have that possibility, and there will be applications that might run on substantial amount of that system.
hero runs. Yeah.
But by and large, you can build a system for the largest typical app, and a largest typical app for a cloud oriented technology could be, a 1U
Hmm.
box. It could be a 2U box.
Yeah. Okay, now moving on, we have a pretty big piece of news coming out of the scientific computing world. This is supercomputers playing a pretty significant role in developing an image of a black hole, the center of our galaxy.
Yes, I saw that. There was another one a couple of years ago that was very similar looking. It was a
Yeah.
donut shaped.
Uh-huh.
And that one was outside of our galaxy. So this one is inside the galaxy. I think that's what made this one more interesting, right?
Yes. It's called, I believe it's pronounced Sagittarius A
Uh-huh.
with an asterisk. And apparently there are a lot of challenges in developing this image having to do with the nature of this black hole. But the Frontiera system at TAC, the Texas Advanced Computing Center, they used nearly 80 million CPU hours from Terra.
Well, what I read was that this was 300 scientists globally
Yeah.
cooperating on this.
Hmm.
Gobs of data. That's a new unit. And from 11 radio telescope observatories. And the last time around, a big problem was how you just haul the data to one place and manage it.
Yeah.
So this is a beautiful example of edge to cloud computing, where a lot of the data is coming from farther reaches of your infrastructure,
Hmm.
and it needs to flow in a place where you can process it in parallel separately and then combine them until you get that blurry donut thing. Now, Andrew Wilshire on Twitter was saying they should have turned on autofocus, which was kind of funny.
Very good.
But it turns out that the galaxy is really pretty dusty, and this is a time average of signals.
Mm.
So with additional observations, it can in fact become more defined, let's say.
Well, that'll be fun to watch. Then we have IBM Quantum making some pretty significant news in that world, because it was a year ago March that they said by next year they'd have a 1,000-qubit chip. So they re-upped on that promise.
Mm-hmm.
They also said 4,000-qubit processor by 2025. So if all of that happens, they could be moving toward, in some workload areas, quantum advantage or quantum superiority, meaning that a quantum system can do things that no classical supercomputer can do.
I think IBM has been doing a fabulous job in their quantum computing effort. From building a community to open sourcing their software to executing on the roadmap to coming up with wonderful additions to how we measure and the metrics. They came up with quantum volume a few years ago, which was measuring the largest circuit. And that was the number of qubits, the fidelity of the qubits, and the connectivity of the qubits. Just last year, they came up with an additional metric called CLOPS for circuit layer operations per second, which is an enhancement over that last one.
Mm-hmm.
They're just really doing a good job. So I applaud them. And it's really encouraging that they're doubling down on the roadmap. And I think they can execute. It is a stretch. It's ambitious, but I think they're doing a great job. And of course, you have to remember that this is a very, very new area.
Mm-hmm.
And there will be a lot of mergers and acquisitions. There already was a few last year that are kind of changing the market when
That's true.
Honeywell's quantum activity got merged with Cambridge Quantum Systems to create Quantinium. There are new players that are, quote, full stack quantum computers that do the software and the hardware. So it's very good. I was very pleased to see IBM's announcement.
Yeah, and it seems sort of un-IBM-ish, if you will, that they're making such bold promises to the world. And maybe this indicates they're very confident in the path they're on. You know, one of the most widely read articles I've written since I came to Inside HPC was a piece a year and a half ago about IBM stepping away from the supercomputing systems business. But here we have them moving toward building these quantum systems. So in a way, they're still in supercomputing.
Yes.
Of a different type. So,
IBM traditionally has a very effective strategy process. And, occasionally I've seen them in retrospect miss a turn. But I think their strategy on quantum computing, on AI, cognitive computing, as they would call it, on cloud, has been pretty valid. I do think that their effort on AI got a setback because it looked like they christened it like 2 days before deep learning became a thing. And from far away, it looked like they had difficulty redirecting it towards deep learning and machine learning in the way that things have emerged. But in general, they've been doing a great job on quantum computing.
Yeah, very impressive. All right. Well, Shaheen, as always, great to be with you. Great chatting. Thanks so much.
Likewise. Thank you very much.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.